Hey guys, got the whole quarantine look going on. Don't y'all like it? Y'all probably thinking I don't look any worse than I usually do, so maybe you're right. You should be on page 83 in your workbook. It's the section B practice problems. You are going to have a section B checkpoint quiz tomorrow. It's a quiz and not a test, so don't panic. Um, on page 83, on number 1, it says a pan of macaroni and cheese is 1/3 full. 4 friends split the remaining macaroni and cheese equally. Make a drawing that represents the situation. So the first thing is we need our pan of mac and cheese. And on the way there, one person got hungry and they ate all but 1/3 of it. So that's all they ended up at the party with was the 1/3. And once they got to that party, 4 friends had to split that macaroni and cheese. So we would have 1, 2, 3. That would give us 1, 2, 3, 4 people splitting that 1/3. So there is part A. Make a drawing showing the situation. All right, and then in B, write a division expression representing how much of a pan each friend gets. So we know that a division expression is just our math problem that we write out. And we know that we had 1/3 of a pan. And that 1/3 of the pan is having to be divided by 4 people. So there we have our representation of our division expression. So don't panic when they ask you for a division expression. That's all they mean. And then it says, explain where you see the division expression in your drawing. Well, I have 1/3 of a pan that's having to be divided into 1, 2, 3, 4 people. So that's how I can explain my drawing. And you know on the quiz, I'm going to want you to go ahead and solve that out. So let's just go ahead and do that. We know that when we're dividing and it involves a fraction, the first thing we need to do is think of our whole number as a fraction also. And then we know that we just slide the first fraction on over, and then we flip or do the reciprocal of the second one, and then we multiply straight across. So I would have 1 times 1 is 1. 3 times 4 is 12. So my final answer, if I asked you how much would each person get, each person would be getting 1/12. And if we look at that, as we had a whole pan, if all of these were here, we know that this part over here has been eaten. But if all of these were here, each person would be getting just one of these little things. Each person would be getting one of these. So they would be getting 1, and then if we counted them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, each person would be getting 1/12. All right, so that takes care of page 83. Flip on over to page 84. And I hope you are taking all of these notes in your workbook. And if you want to take your workbook home tonight so that you can look through it for the quiz tomorrow, that's fine. Just make sure you bring it back because we will be using it again tomorrow. Okay, this one. Make a drawing of the expression 1/5 divided by 2 using the tape diagram. So it gives you a piece of tape, and it tells you that that tape altogether is one big one, okay? And all it tells us is that this is fifths. So the first thing we can do is we can go ahead and make it into fifths. Okay, so I have 1, 2, 3, 4, 5. So I know that each little section is 1/5. And then it tells me that I'm supposed to take the fifths and divide each fifth by 2. So if I did that, then this fifth, I would have 1, 2. This fifth, I would have 1, 2. This fifth, I would have 1, 2. 1, 2. And 1, 2. So that is A. We're making a drawing of the expression 1/5 divided by 2. And in B, it asks you where do you explain where do you see this? Well, I have all of my 1/5 and I have divided them each by 2. So that's how I see 1/5 divided by 2. And then in part C, it asks, what is the value of 1/5 divided by 2? Well, again, we know that anytime that we're dividing and it involves a fraction, that we first need to look at our whole number as a fraction also by putting it over 1. We know that we just slide our first fraction on over. We flip or do the reciprocal, and then we multiply. So I would have 1 times 1 is 1. 5 times 2 is 10. So my final answer is 1/10. And I can describe this in my drawing because if I look at this and I see each one of these would be, if I divided them all out, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each little section would be 1/10. Okay, number 3. Just a minute, let me get this cleaned up. All right. Number 3. Mai has a strip of paper that is 3 feet long. She cuts it into 1/4 foot strips. How many 1/4 foot strips does Mai make? Now, first of all, previously in our lesson, I would ask you to just, kind of reason what your answer could be. For this one, she has a strip of paper that's 3 feet long. And right now, it's just one strip of paper. It's 3 feet long, but it's just one strip of paper. And then she asks, how many 1/4 strips foot does she make? So I know that she's going to be making a whole number, okay? There's no way she's going to be making parts of a strip. She's going to be cutting it into strips. So now she's going to have more than one strip. So we know that our answer is going to be a whole number. All right, and then if we take that and we look at it as a diagram, if Mai had a 3 feet strip, okay, she's got 3 feet of that. And then if Mai took that and it says she did it in fourths, so we would have each little section would be 1/4. All right, so then it says, how would we write an expression, a division equation, expression equation, same thing, to represent my answer? So I know that she had 3 feet and she was dividing that 3 feet by 1/4. So now there's my division expression or my division equation. Again, means the same thing, equation, expression. So we're now dividing with fractions. So we know when we're dividing fractions that the first thing we need to do is look at our whole number as a fraction also by placing it over 1. And then we follow our rules just like we would when the whole number was on this side. It doesn't matter which side it's on. You always follow the rule. The first fraction slides over, so I have 3 over 1. Then we do the flip of the second one, or the reciprocal, and we multiply. So we would have 3 times 4 is 12. 1 times 1 is 1. So the final answer is 12 over 1, or 12. And that makes sense because I know it was going to be a whole number of strips that I had. So if I take the 3 feet and I divide it up into 4th strips, I know that I'm going to end up with more strips than I started with. So she is able to get 12 pieces out of the 3-foot strip. Remember, she was taking the whole 3, dividing it by fourths. We knew we were going to get a whole number because getting a fraction wouldn't be a reasonable answer. So if we had done it backwards, we would have ended up with 1/12. And that should have triggered us to say, okay, I know my answer has to be a whole number, so I know that I probably divided backwards, because remember, it does matter which way we divide when you're doing it. Anytime you're dividing, it matters what order you go in. You have to think, am I dividing up the fraction between like a whole number of people, or am I dividing up a whole into little fractions? Okay. Now, on page 85, it just asked us to find the value of each expression. So I know if I have 5 divided by 1/4, I first have to look at my whole number as a fraction by placing it over 1. We slide the first one over. We know that we always do the reciprocal, or we flip the second one, and we multiply. Five times 4 is 20. 1 times 1 is 1. So my final answer is 20 over 1, or 20. B. Now this time, my first number gets a little larger. It's now I'm going to have 6 of them. But I'm still dividing them into fourths. So if I just, kind of reason in my head, I'm thinking, okay, now I have more of it, but I'm still dividing it into fourths. So I'm thinking that my number is going to be higher than 20 because now I have more of it and I'm still dividing it by fourths. So I'm going to check that. It gives me 6 divided by 1/4. I look at 6 as a fraction by placing it over 1. We always slide the first one. We flip the second, and we multiply. 6 times 4 is 24. 1 times 1 is 1. And 24 over 1 is equal to 24. And that's reasonable because I just said a minute ago that I went from 5 to 6, but I was still just dividing it by fourths. So I should have a little bit higher number. Now, remember the pattern we talked about last week, or 2 weeks ago? Whoa, that's been a long time, hasn't it? We said that dividing by 1/4 is the same as multiplying by 4. And has that turned out to be true? Okay, if we look back at our patterns, yeah, that's true, isn't it? Okay, on the next one. Now we have 3, and we're dividing it by 6. So I have less than what I started with earlier, and I'm dividing it into littler sections or bigger sections? Is 1/6 a littler section or a bigger section than 1/4? So let's think about that. If it was a pie, if I had it divided into fourths, it would look like that. But if I had my pie and it was divided into 6, it would look like that. So would you rather have a 1/4 of a pie or a 1/6 of a pie? I'd rather have a 1/4, okay? Because remember, when we work with fractions, if they have the same numerator, the bigger the bottom, the less or the smaller it is. So this should trigger me to thinking something about my number here. So let's think. If we have just 3 of them now, we still look at our whole number as a fraction by writing over 1. We still follow the rule. We're dividing fractions, so we slide the first one on over. We do the reciprocal, or we flip, because dividing by 1/6 is the same as multiplying by 6. 3 times 6 is 18. 1 times 1 is 1, and 18 over 1 is 18. So on the next one, I still have those 3 whole ones, and I'm dividing it into 7ths now. So should my number be higher or lower than this number? I still have 3 whole ones, but instead of dividing it into 6, now I got to divide it into 7 people. So should this number be higher or lower? Just in my reasoning, I think, okay, if I'm dividing it by littler slices, then this number should be bigger. Okay, and I'm going to check my theory. We know that we make our whole number a fraction by putting it over 1, and we follow our rule of dividing fractions. We slide the first one on over. We flip or get the reciprocal of the second one, and then we multiply, because dividing by 1/7 is the same as multiplying by 7. 3 times 7 is 21. 1 times 1 is 1, and 21 over 1 is equal to 21. So my reasoning was right. When I still had the same 3, but I was having divided now into even more little pieces, then I'm going to have more of those little pieces. So that's how I come out with 21, and that's a reasonable answer for me. Okay, on page 86. On page 86, actually there's a typo in your book. I noticed this when I was going through it a little earlier. It should say 3 ounces is 1/4 of the package of sunflower seeds. So scratch out the 3 ounces of 1/4 and change that to is. 3 ounces is 1/4 of the package. if it tells me that 3 ounces is 1/4 of the pack of sunflower seeds, how many ounces of sunflower seeds are in the whole package? So the first thing I need to do is reason about my number that I'm going to get. I know that my number should be a whole number, and it should be more than 3 ounces, because those 3 ounces only represent 1/4 of my whole package. So if I think about my package of sunflower seeds, I'm going to draw this, and that's just going to be my pack of sunflower seeds. I know that it was in fourths, and I know that 1/4 of it is 3 ounces. So I have to say to myself, okay, if 1/4 of it is 3 ounces, then this is also going to be 3 ounces. This is going to be 3 ounces. And this is going to be 3 ounces, because it told me that 1/4 is 3 ounces, so they're all equal, so each would be 3. And then it says, to show or explain my reasoning. Okay, well, I've shown it with my graph, and then I can explain it. I can say I have 3 I'm sorry, do y'all hear Bailey whining? She's wanting me to talk to her and let her out. So I have 3, and that 3 ounces was 1/4. So I have 3 ounces. That was divided by fourths. So I look at it as 3/1. It slides on over. I flip or do the reciprocal for the second, and then I multiply. So 3 times 4 is 12. 1 times 1 is 1. So I end up with 12/1, or 12. And that makes sense, because I knew it was asking how many ounces were in the whole bag, so I knew it was going to be a whole number. I knew it was going to be more than 3. So that's a reasonable number. And then if I look at my graph that I drew of my pack of sunflower seeds, I could just count. I have 3, 6, 9, 12 ounces. I hear you, Bailey, but I can't take you out right now. You're going to have to wait. All right, number 6. A person drove 5 miles. That's 1/3 of the distance from their home to work. How far is it to the person's home to work? And show or explain your reason. Okay, same type of scenario. I know that the person drove 5 miles, and that was only 1/3 of the distance from their home to work. So here's the whole distance from home to work. The whole distance from home to work. And it told us that it was thirds, okay? And we knew that 1/3 of that trip was equal to 5 miles. So if it was divided by thirds and each was 5 miles, because they're distributed evenly, then that would let me know that the whole trip from home to work is 5, 10, 15 miles. If asked to write an expression, again, don't panic over the expression. You know you're going to be dividing fractions. It would ask you to write a division. You know that it's going to be a whole number. So if you have the 5 miles divided into thirds or by thirds, we look at the 5 as a 1. We slide it on over. We flip the second. And we multiply. So we would get 15 over 1, which is 15. Now, so if they ask you to write a division expression, all you're doing is writing out that 5 was 1/3 of the total trip. We knew we had to come out with a whole number because it wouldn't make sense that the total trip be a fraction of the way, because 1/3 was 5 whole miles. So we knew we were going to come out with a whole number that was bigger than 5 miles. So we have 5, 10, 15 miles. All right, next one. There are 4 liters of water. How many half-liter bottles of water is that? So let's think of our reasonable answer. Do we think it's going to be more or less than 4 liters? It says how many half-liter bottles of water is that? Well, if we have 4 whole liters of bottles of water, and we want to know how many half liters that would be, then we know that we are going to come out with a whole number, correct? Okay, so we have 4 whole liters that we're dividing in halves. So we would write it as a fraction. We slide over the first. We flip or get the reciprocal of the second, and then we multiply. 4 times 2 is 8. 1 times 1 is 1, and 8 over 1 is 8. And this is a reasonable answer. I knew that if I was taking 4 whole ones and splitting each of those in half, then I would end up with more. I'd end up with a higher number. If it asked you to draw a diagram of this, okay, you have 4 liters, so each one of these is a liter. And then it told you to divide each liter into halves. So how many half liters would you have? 1, 2, 3, 4, 5, 6, 7, 8. I know it's not asking you to do the diagrams and expressions on every one of them, but I'm doing that so if on the quiz tomorrow, if that helps you to draw a diagram, even if I didn't ask for one, if it helps you to draw the diagram, then draw your diagram out. On state tests, they don't care if you draw your stuff out as long as you get that final answer. So if it helps you to draw a diagram every time, then draw a diagram every time. Okay, the next one. 4 friends split a half a pound of dried fruit equally. How many pounds of fruit does each friend get? So I have to think about my reasonable answer. Together, all we have is a half a pound starting out with. We don't even have a whole pound. So here's like that's going to be my dried fruit. And right now, I know that all I have of it is this half. Okay, we only have half the pack of dried fruit. Somebody else already ate the rest of it. And then that had to be split by 4 people. Okay, so 1, 2, 3, 4. So how many pounds of fruit does each friend get? So if I look at it like if it was all here, and each person only gets one little piece, then each person would be getting 1, 2, 3, 4, 5, 6, 7, 8. Each person would be getting 1/8. And if it asked you to write an expression or an equation to show this, I have half a bag of dried fruit that's having to be divided by 4 whole people. We're dividing fractions, so we always want to look at our whole number as a fraction. We follow our rule of dividing fractions. We have 1/2. The first one always slides over. We flip or get the reciprocal of the second, and then we multiply. 1 times 1 is 1. 2 times 4 is 8. And that's exactly what our diagram said it should be. And think about, it's a reasonable answer. We knew it was going to be a smaller fraction than 1/2 because that's all we had to start with. And then that 1/2 had to be divided up 4 more times, giving us 1/8. Okay, now the next one, they try to kind of throw you a curveball. Each book is 7/8 centimeters thick. How thick is a stack of 10 of these books? So on this one, we have to think, am I dividing or am I multiplying on this one? And actually, even though I've been dividing all the time, I'm still multiplying, right? Because when we're dealing with fractions and division, we get the reciprocal or the flip and then we multiply. So on this one, the easiest way to think about this, okay, you have books, each one is 7/8. So you have 7/8 10 times. So now I'm just multiplying fractions. I have a 7/8 10 times. We still always look at that whole number as a fraction, but remember now we're just multiplying. Rule for multiplying fractions. You just multiply straight across. You don't flip anything when you're multiplying fractions, do you? So we have 7 times 10 is 70. 8 times 1 is 8. The board's still wet right there. Okay, so we know that now we're ending up with an improper fraction. And so I know I'm going to have a whole number part and possibly some leftovers. But that makes sense. I knew I was going to have something larger than 7/8. I knew I was going to have a whole number because I have that 7/8 10 times. So if I go to the side and do the math, just like I would read top to bottom, 70 divided by 8. 8 won't go into 7, so I placeholder 0. 8 goes into 70. 8 goes into 70, I think 8 times 8 is 64. then I subtract, have to borrow here. 10 minus 4 is 6. Okay, so 8 won't go into 6. There's nothing else to bring down. So I have a remainder of 6. So I have 8 whole ones and 6/8 left over. That makes sense. So now I have a stack of 10 of them would be 8 6/8 centimeters. Now, if you wanted to go ahead and break that all the way down, putting it in simplest form. Now, I didn't ask you to, but if I was putting it in simplest form, each of these could be evenly divided by 2. So I still have my 8 whole ones. 6 divided by 2 is 3. 8 divided by 2 is 4. And it was centimeters. So either of these answers would be correct. This one is just the more simplified version. It's broken all the way down into simplest form. Okay. All right, next one, number 9. The area of a poster is 3 square feet. The poster is ½ foot wide. How tall is the poster? Now this has us drawing back on area that we did way back, but gotta hold on to that knowledge. We gotta keep it through state test and into next year and into the future. So the first thing we have to think about is area. We know that area is equal to length times width. And then it gave us some of the parts of this, okay? It told us that the area is 3 feet. So we know what the area total is. And then it told us that the width is 1/2. And I know that length times width gives me area. So I have to determine what would I have to multiply 1/2 by to give me 3. So I start thinking of what I know about multiplication and just speaking English. I know that this is of, right? Blank of 1/2. And I know that this means I'm multiplying. So if I think to myself, half of what will give me 3? Half of what is equal to 3? Just reasoning, I say half of 6. That's just what I say off the top of my head. Half of 6 is 3. And then I can check myself. If I put in 6, we know is the same as 6/1. We know of means multiply. And we have 1/2. And if I do the math, multiplying straight across, 6 times 1 is 6. 1 times 2 is 2. I end up with an improper fraction. I go to the side and do the math. 6 divided by 2. 2 goes into 6 3 times. 3 times 2 is 6. And I have 0 left over. So how many whole ones? 3. And what did it tell me it was supposed to be equal to? 3. So what was missing? My 6. We have to look at that. English to Mathlish. English and Mathlish. Of is half. We knew we were multiplying. Half of what number would give me 3? I think it's a 6. So then I do the math and I find out I was right. It is 6. All right, next page. We are now on page 88. Now on this one, it is a little bit backwards than what we've been doing. It's been giving you a situation and you have to draw the diagram. Now it's giving you a diagram and asking you to come up with a situation that could explain that diagram. And the one that they give you, just a second, let me dry the board off a little better. It's still a little wet. Okay, they give you this. And they tell you that each one is 4. Now, you can have a lot of different case scenarios going on in your head right now, lots of different little stories, but one easy little story we could say is that this is the 3rd of my trip that I'm taking. Each third was 4 miles long. How long did I drive altogether? Okay, so 1/3 of my trip is 4 miles. So, I traveled 12 miles. One case scenario. Okay? Again, you may come up with many. I'm just showing you an example of what they would be asking for on test if they give you a little diagram and tell you to write a story about it. Tell you to give them a situation that would fit that diagram. All right, next one. They give you this. And they tell you that each one of these is 1/3. Okay, and just a simple little problem that could fit this. If I had 4 students who all drank 1/3 of the bottle of milk. Okay, so 4 students each drank 1/3. So they all drank, and then let's see, we would have 4 students that drank 1/3. So if we look at this as a fraction, we would have 4/1 times 1/3, which would give me 4 times 1 is 4. 1 times 3 is 3, so it would give me 4/3. Now, that's an improper fraction, so if I went over to the side and did the math, 4 divided by 3, 3 goes into 4 one time. 1 times 3 is 3. I subtract, and I get 1. So this would be equivalent to 1 whole 1, and 1 was remaining. We were dealing in thirds. And it makes sense that all together they drank 1 1/3, because if we look up here and add them together, we would have 1/3, 2/3, 3/3, which gives us 1 whole, because 3/3 is equal to 1 whole, and then how much more? 1/3. So 1 whole plus 1/3 would give me 1 1/3, and that's what I got down here when I did my math. So again, your story can be different. This is just one example of something you could give for a possible answer on test. Part C, on this one, they give you this diagram and they have it divided in thirds, and then they also have the first section divided into fourths. Okay, so something on this one, it could be like when you got to the party, you had 1/3 of a bag of chips. 1/3 of a bag of chips. And you had to split between 4 people. Between 4 peeps. Okay? So if you have 1/3 of a bag that you had to split between 4 peeps, how much would each person get? Each person would get how much? And let's just go up here and take a look. If all of this was here, and this one little part is shaded in like they have it in your diagram, how much would each person get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each person would get 1/12. And that makes sense if we do the math on it. We would have, if they asked for an expression, you would have 1/3 of your bag of chips that has to be divided by 4 people. So we would slide that 1/3 on over. 4 is the same as 4/1, which we know when we're dividing fractions, you flip. So we would have 1/4, and then you multiply. So 1 times 1 is 1. 3 times 4 is 12. So 1/12. Again, we got 1/12. So now we've represented in 3 different places how this diagram could be used to show division of fractions. Okay, and now problem 11 on page 89. Problem 11. That problem's a little long, so go ahead and be reading that problem while I get this board cleaned. It's talking about the time it takes the Earth to revolve around the sun versus how long it takes some of the other planets to revolve around the sun. Okay, it says that the Earth takes 1 year to orbit the sun, which we all know that. It takes 1 year for us to go all the way around. And it says during the time it takes the Earth to make 1 orbit around the sun, Mercury makes 4 full orbits of the sun. How many years does it take Mercury to make 1 full orbit of the sun? So we have to think about that for a minute. Now, would my answer be more or less than 1? Because if it takes us 1 whole year and they can do it 4 times in the amount of time that we do 1 year, then I know that it doesn't take them as long, does it? Okay, so I know my answer is going to be a fraction because it's going to be less than 1 year. I already know that. Okay, so I have 1 whole year that is being divided, and this whole year they can do it 4 times in the amount of time that we do. So I have, looking at both of these like they're fractions, if I have 1/1, I just slide it on over, I flip the second, and then I multiply. 1 times 1 is 1. 1 times 4 is 4. So it takes them 1/4 of a year. Okay, so it takes them 1/4 of a year. They can do it 4 times faster than us. So 1/4 of a year. Now, the next one. During the time it takes the Earth to make one full orbit around the sun, Saturn makes 1/29th of a full orbit. How many years does it take Saturn to make a full orbit of the sun? Now, this one I have to think in reverse. In the amount of time that it takes us, that 1 year, Saturn just moves just a teeny tiny bit. They only do 1/29th of what we're doing in that 1 year. So if we have 1 year, and then we look at Saturn, they're only doing 1/29th of that. They're just barely moving along. And I look at this like a fraction. I would slide this on over, 1/1. I flip the second, and I multiply. 1 times 29 is 29. 1 times 1 is 1. So 29 years. And that makes sense. That's a reasonable answer. We said that it was going to take them a lot longer than us because they're only barely inching along at that 1/29th. So it makes sense that I come out with a high number. So to relate this all back to each other, we have to remember that dividing by 1/29th is the same as multiplying times 9. Dividing by 4 is the same as multiplying times 1/4. We have to get that, what answer is reasonable. We have to really focus on that. That way we don't ever divide in the wrong direction because it does matter what order you divide in. So I hope that makes it clear as mud for everybody for tomorrow's quiz. You can go back. Again, you can take your workbook home if you want to. Just make sure you bring it back tomorrow. This whole time that I'm out, you guys can just go ahead and take your workbooks home with you and look over stuff again at night with the video so that you can stop it, go over it as many times as you need to. I am always available. You can always get to me by commenting, a private comment to me on Google Classroom, or you can go to my email. You know, you can always email me. So I will see you guys tomorrow, and let's see if Bailey wants to make an appearance tonight. Let me grab y'all off there for a minute. Let's see. Bailey! Bye-bye. There he is. Say hi, Bailey. And there comes Harley. That's Harley. The little white one is Albie. And I don't know where. I have one more cat. Her name is Finley. She doesn't really like people. She's probably hiding. But anyway, tell them night, Bay. Say night-night, guys.